Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Today we will talk about indicator of social vulnerability in spatiotemporal modeling perspective. This is the continuation of previous presentation, but in different perspective. This presentation will be split into some parts. The first part is about introduction, concept of spatial data, concept of temporal data, and also concept of spatiotemporal data. And then indicator of social vulnerability, daily commuting, the implication of daily commuting to the indicator of social vulnerability, solution for this problem, case study, conclusion, and the last, the reference for this study. Okay, let's go on to the next part. The first part we will talk about introduction. For the first, we will talk about spatial data. Please check the simulation out. This is the real object in the world. And then the surveyor records this object. And then the result of recording will be processed to be an information. The result of recording will show the geometry of object with the coordinate in every point. And also will be shown in tabular form. The number of points with the value as coordinate. And this will be spatial information based on data processing. Like when I mentioned in 2011 that spatial data are data that have a spatial component. It means that data are connected to a place in the earth. How about the temporal data? Please check the simulation out. At the specific time, we have the first condition. And then, after some period of time, the first condition has been changed to be the new condition. This phenomenon will be recorded to be the data. And then the data will be processed to be an information. Like this table will mention that there are time period change and also conditional change. As written in 2016 mentioned that temporal data is implied data that represent state in time. Temporal data is collected to analyze weather pattern and other environmental variables, monitor traffic conditions, study demographic trend, and so on. And then let's go to talk about spatiotemporal data. The spatiotemporal data has two phenomena. For the first, please check the simulation out. At specific time, in the specific location, we have the first condition. For example, a young boy in under 14 years. And then, after some period of time, in the same location, the first condition has been changed to be the new condition. For this situation, the young boy has been grown up to be a man in 24 years old, for example. And then, how about the second phenomenon? Please check the simulation out. At specific time, in the specific location, we have the first condition. For example, the same condition with the first phenomenon, that is, young boy under 14 years. But after some period of time, the first condition has been changed to the new location, but with the same condition, that is, young boy under 14 years. This situation shows that a young boy moved out from the first location to the new location in some period of time for her or his business, for example, for school. Hunt and Pay in 2012 mentioned that spatiotemporal data are data that relate to both space and time. Typical examples of spatiotemporal data mining include discovering the evolutionary history of city and land, uncovering weather patterns, predicting earthquake and hurricane, and determining global warming trends. Okay, let's go on to the next part, that is the indicator of social vulnerability. Based on the concept of spatiotemporal data, the indicator of social vulnerability also can be split into two groups. The first group, the indicator that will change in some period of time but in the same location. The indicators that include in this group are age, sex, income, education, household, and also mobility. This group will never have the problem with the aggregation of administrative units. How about the second group? The second group is the location will change in some period of time. The indicator that included in this group is population. For the specific variable is commuting. This group will have the problem with aggregation of administrative units because the moving out of people from the first location to the new location cannot be limited only based on administrative units. Okay, let's go on to the next part, that is daily commuting. So what is commuting? Please check the simulation out. For example, at 6 a.m., an employee still in the home. And then at 8 p.m., the employee already in the road to go to his office. At 9 a.m., the employee already in his office. And the last, at 4 p.m. or 5 p.m., the employee back to the route again to go to his house. Based on the Cambridge Dictionary, commuting is the activity of traveling regularly between work and home. For more explain about daily commuting, please check this figure out. In this figure, there are three domains. The first is spatial domain, second is temporal domain, and the last is attribute domain. All of the domains are related one to the other. Spatial domain will show the specific location that there are some people in there. Temporal domain will show how many times the people will be stay in the same location. And then the attribute domain will show how many people in the same location at the same time. And then all of domain will be presented in a map. This figure, mentioned by Martin et al. In 2015. Martin et al. Also mentioned that conventional population mapping is based on the representative of static zone data within static zone boundaries. Even when such maps are created and presented through the friendly dynamic media of geographical information system or online mapping, these essential characteristics remain unchanged. Numerous application examples require more time-specific population distribution than those presented by conventional population maps. These include emergency planning and the organization of accessibility, service, and facilities. For more detail again, please check this graph out. This graph shows the function based on the change of period time to the population rate. The function split into two specific locations. The first is working area and the second is housing area. And based on the result, we can split the change of period time into two groups. They are nighttime and daytime. This graph based on Gregory in 2015 study. Based on the graph, population rate in daytime and nighttime are different. At daytime, the population rate is maximum in working place or central business district. But at nighttime, the population rate is maximum in home or housing area. Okay, let's go on to the next part. That is the implication of daily commuting. For more detail about the implication of daily commuting, please check the simulation out. The real world has some phenomena. They are about spatial aspects like housing area and also working area, and also about temporal aspects like daytime and nighttime. Based on different phenomena, people have many different activities. Their activity should be recorded based on the reality, not only based on the aggregation of administrative units, because the result of data recording will be analyzed for social vulnerability index, and then the result of social vulnerability index will be used for decision making for social vulnerability reduction, and then the decision will be implemented to the real world. So, if the data is not representative with the real world, the implementation will not match with the reality. Okay, let's go on to the next part. So what is solution for this problem? The first solution, we need to separate the difference of phenomenon of indicator in different layers. The first layer will be used for the indicator that have no problem with the aggregation of administrative units. The indicators that include in this layer are education, sex, age, mobility, income, and also household. And then the second layer will be used for the indicator that have a problem with the aggregation of administrative units. For example, for daily commuting. This layer will show the spatial aspect, that is, housing area and working area, and also temporal aspect, daytime and nighttime. This solution, based on Freire et al. In 2013. This study, the authors split the map into two layers. They are dynamic population in daytime and nighttime for the first layer, and the tsunami risk condition for the second layer. And then the combination of these two layers will be used for the assessment of tsunami evacuation route. Okay, let's go on to the next solution. So how to get the data of human daily activity or daily commuting? There are some solutions. The first, Based on building population estimation, based on Geiger K in 2015. Second, based on mobile call data, based on study Kang C et al. In 2012, search solution use social media based on Peter et al. In 2017. Okay, let's go on to the next part, that is case study. For this study, we will try to mention study of Geiger K in 2015 with the topic spatiotemporal building population estimation for highly urbanized area using GIS. Location for this study is Western Tokyo metropolitan area. This study used model estimation like this. There are some symbols. PP is building population estimation. AP is total population study area. BA is area of building. BF is number of floor of building. I for specific of building. C category of building, and P for a specific time. Based on model, so the author spirit building category. There are some category like home, business office, education, retail and service, leisure and hotel, public institution, main train station. This is the some building in this study. Okay, this is the simulation for this study. For example, this is an area have some population SEP and have some building. Every building have an area and also number of floor, that is building floor. Every building also have some category, like for education, household, and also income. Every category have a specific building. For example, for category education, there are elementary school, junior high school, and also senior high school. This is for specific category. And then specific time, and this is the result for this study. Start for 5 AM, you can see the change of population until 11 PM. Start from morning until in the night, the evening. You can see that in the morning, population is maximum in housing area, but start from 8 p.m. until 9 p.m. population maximum in working area. Okay, let's go on to the next part. That is the conclusion for this study. There are some conclusions. The first is there are two groups in indicator of social vulnerability based on spatiotemporal data. The first group is the indicator that will change in some period of time but in the same location. The same second group is the indicator that will change the location in some period of time. The first group will never have the problem with the aggregation of administrative units, but the second group will have the problem because the moving out the people cannot be limited only based on administrative units. To accommodate this phenomenon, we can split the indicator become two layers. The first layer is used for the group that will never have the problem with the aggregation of administrative units. And the second layer is used for the group that will have the problem. This scenario based on Frey et al. In 2013 study. This study split the daytime and nighttime population condition as the first layer and tsunami risk condition as the second layer. And then this is some reference that used in this study. Okay, this is the last presentation. Thank you for your attention. See you in the next time. Assalamualaikum warahmatullahi wabarakatuh.